So the next video is the role of statistics activity. This is after you've done your pre-planning, you've planned your experiment, and now we want to move beyond data visualization to statistical analyses. And statistical analyses, whichever one's appropriate, is well beyond the scope of this video. But what I really want to do is help you motivate the need for statistics in supporting your conclusions with your students. So we want the students to be able to support their conclusions through the proper use of statistical methodologies. So that's what we want them to know. We want them to recognize the need for statistics. And why can't I just stop with this graph? I can show the differences with this graph. I've done this great job with my data visualization. Why do I need to go a step further? And we want them to recognize that need for statistics and appropriate statistical test that moves them beyond their data visualization. So again, we're still in this last aspect of the analysis and conclusion portion of our iCure. So the students have already conducted their experiments and they're just putting their final touches on their posters and they're making their conclusions. So we want to emphasize that they have to justify their conclusions of their research beyond visualizations. It's not enough to show that the bars aren't the same height. It's not enough to show that these two numbers are different. We need to help them understand what role statistics have to provide evidence beyond chance. So this activity is kind of fun. So suppose you're trying to prove if somebody has extrasensory perception, so ESP, so their sixth sense, you say, so their ability to read your mind, right? So early on, this psychologist developed these cards that had different shapes. The colors are relevant here, but they had different shapes. And he would present a subject that claimed that they had ESP with these cards. And they were obviously face down, and they were supposed to tell what shape was on the card just by seeing it face down. They can't see through the card. They need to be able to have that sixth sense or that extrasensory perception in order to guess the right shape. So suppose you're doing this with your experiment and you want to prove if somebody has ESP. So you give them the card, you put the card down, you pick one of the cards out of the stack, you put the card down, and your test subject can either get it right or they'll get it wrong, right? So there's two options here. And so suppose you give the card to this person that claims they have ESP, you give them the card and they guess correctly. What if they guess correctly? Can you conclude that they have ESP? Would you conclude that if they have ESP? So these are the questions you would ask your students. So you're gonna go, why or why not? So students are like, well, they could just be guessing. They could just be guessing and they happen to get it right. So we want to know, well, what is the chance that the subject got it right just by guessing? Turns out that's 20%. There's 5 cards. Your chances of getting it right by simply guessing were just 20%. So we'll prompt the students to ask, given your knowledge of experimental design, how would you improve the experiment? So most of them will come up with the idea of replicates. They're like, well, one card is not clearly enough in order to show this. So now, suppose you're going to give them 25 cards to guess. So we're going to lay them 5 down and we're going to give them a card. And now they have 5 different shapes to choose from and you're going to give them 25 cards. How many would you expect the person to get right? Just by chance. How many, if I don't have ESP, how many do you think I would get right? So if I don't have ESP and I don't have that condition that we're trying to test for, how many would I get right? Turns out I would probably get about 5 cards right just by guessing. So we actually have a distribution, and this is where we're going to move from basic data visualization into showing how likely what we saw in our experiment is beyond that of chance. So let's continue with the cards. So what number correct would convince you that they actually had ESP? So it turns out that this is actually mini stat lesson here, that this is actually a binomial distribution because the response, our dependent variable, was yes, they got it right, or no, they were not right. So what the x-axis on the bottom represents is the number of successes, the number of cards they got right. So you'll notice that 5 is the highest peak, and 5 is what we would expect somebody to get right if they were just guessing. And and likely they could get 4 right. They could also get 6 right. But that chance dwindles. So if you were going to make a line to determine whether or not somebody really had ESP, how many cards would they get right? How many cards would you want them to get right? What about 12? Do you know the chances of a person getting 12 cards right is 0.1% if they're just guessing? So what's more likely here? That they don't have ESP and they just by chance got 12 cards right, or maybe they have ESP. So that's where we're going with our hypothesis, and that's what statistical analysis helps you decide. So typically, you'll notice that we usually make this cutoff. So let's say, for example, the probability of the subject guessing 9 or more cards right is about 4.68%. So again, the probability that somebody guesses right 9 or more cards is 4.68%. That's not a very big number. That might be a number you're comfortable with. It may not be. So this idea is we're going to say if they get 9 or more cards right, so they exhibit ESP traits. So if that's our cutoff for our experiment, 9 or more. So this is getting into a little bit of a mini stats lesson here. So typically our standard cutoff, which you've probably already been familiar with, but you may not have remembered why, is about 5%. Because 5% is our chance of saying, oops, somebody has ESP when in fact they actually didn't. Because it is possible that a person gets 9 cards right, but it's just not probable. And that's what our p-value is. Our p-value is the probability that that subject gets that observed number of cards right or more extreme, given that there's no ESP present. So in other words, the smaller the p-value, the more extreme evidence that you have against the null hypothesis. So the reason why I bring this up is every single statistical test is going to provide you with a p-value. And that p-value is going to represent that evidence that you have against your null hypothesis. So when that p-value is very, very large, you don't really have that much evidence because you're really not that far away, and it actually could happen by chance. But when you have a very small p-value, you're showing statistically that there might be a difference between the two groups. There are some debates surrounding p-value that's beyond this video that you probably are familiar with. But in general, a smaller p-value indicates that there is a difference between the two groups. There's evidence against your null hypothesis, evidence against that hypothesis of no change. So this is why we've identified all of the factors of interest and our variables that are dependent variable and our independent variables. All of those things are going to play into which statistical analysis is going to be appropriate. Either way, every statistical analysis, by and large, is going to end with a p-value. It's going to end with some number or some evidence for or against your null hypothesis. So there's actually some flowcharts in the activity handouts that will help guide your students. So if I have 2 groups, then I go this way, and there's a whole bunch of different flowchart options for them. If I have pre and post data, I go to one flow chart. If I have categorical, non-numeric data, I go to another flow chart. And it helps them decide what test is appropriate here, because otherwise I'm gonna have to lump all of statistics into one 5-minute video. So that's not gonna be possible. But what we can do is use the variables that we've already identified and the types of variables that we've identified to help us pick the proper statistical test. And there's a number of online tools that can help you do that, but they're a lot easier if you know which test to use and if your students understand how to interpret the results that they're getting. What does it mean when my p-value is very small? What does it mean when my p-value is very big? How do I interpret my results? So again, the same website, and you don't have to use this website, again, it's free, but it offers the opportunity to analyze, for example, to compare two proportions, to compare two means, to compare two different groups. And there's more options on that website to compare more than two groups. So it helps you decide what type of analysis is appropriate for your data, and it'll allow your students to make the appropriate conclusions.